Okay, this is 4.3 and 4.4. The first problem gives us an equation for a parabola that has a vertex at the origin and a directrix x equals negative 3. Now, we're going to want to graph these first just to get a picture. I think that's helpful. This thing has a vertex at the origin, and the directrix is the line x equals negative 3, so that's this line here. So we know that the vertex then opens this way, or I mean the parabola opens right or left, because technically the definition of a parabola is all the points that are equal distant from the focal point and the line and the directrix line. So all these points are equal distant from the focal point and from the directrix. So that's kind of a different way to look at things. We have a whole table of information now that's on the formula sheet that gives us everything we need to know. So the equation for the directrix in terms of the vertex and the point and this point P. The focal point, the focal length is that P, by the way. That's what P is. And so we're going to write these equations a little bit differently. All right, so we have a parabola that opens right or left, so we're going to be dealing with the column in the right here. And for this one, we know that P is 3. So we can use this equation right here, which is y minus k. This is set at the origin, so h and k are 0, so it's k squared equals 4p times x. So basically we just need to plug in p. And if you're not sure what p is, you can always find it too by using, like I said, we're in the right or left column. You can find it by using the directrix. The directrix has the equation x equals h minus p, which h is 0, so it's going to be, in this case, x equals negative p. And we know that x equals negative 3 for our problem, so p must be 3. So p really is the length between the directrix and the vertex, or the vertex and the focal point, either way. That distance is 3. So you plug in 3 for p and you get y squared equals 12x. And that's your equation for the sideways opening parabola. And that goes in here then. We're using this second one, so it's a is 12. Okay, the next problem gives us an equation of a parabola again. This time, we recognize this form because it's a times x minus h squared plus k. It's actually easier to do it in this form because we're used to that, and this problem's a lot harder to do it in the other form. But you could do it in the other form, technically. If you use this table, you can rearrange this. This has x squared, so you're using the one where x is squared. This one has y squared. So you would use this column right here, and you would find that you know the vertex. If you basically solve this one to get it in this form, once you have p, you can then use that right here into the equation for. I'm sorry, you'd actually just, once it's in this form, you get the vertex right away, h and k. And then from there, you can figure out the rest of it. But it's easier to do it the way we used to do it, which is that when it's in vertex form, we know that if we compare this is negative 8 times x plus 8 squared plus 6. So I'll make this minus negative 8 so that you can easily see that h must be negative 8 and k must be 6. So negative 8 comma 6 is the vertex. That goes right here. And then the direction that this goes, we know this opens down. So we know this thing goes through negative 8, 6, which is up here. And we know it opens down. So when it says the direction in which the parabola curves away from the vertex, it'll be down. Okay, the next problem says find the equation of a parabola with given characteristics. So once again, I always draw a picture first. Say as a focus at 8, 0, 1, 2, 3, 4, 5, 6, 7, 8, which is right here. And the directrix is the line y equals negative 8. 1, 2, 3, 4, 5, 6, 7, 8. So here's the directrix. That means that this parabola looks like this, because we know that all the points are equal distant from, this distance here and this distance here is the same. We also know that p is 8 now, which is pretty handy. But we can use that table of information that we have right here to figure out what we're looking for. So we know we have a parabola that moves right or left, so we're in this column right here. And they want an equation, so we're going to use this equation here, which is y minus k squared equals 4p times x minus h squared. And h and k are 0, so we have y squared equals 4p. We know p is 8, so this becomes 32 x squared. Or I'm sorry, that's not squared. So just 32x. But they want this solved for x, so I'm going to divide both sides by 32. So if we solve it for x, we get x equals y squared over 32. That's what I put here. And if you're not sure that P is 8, the distance from the focal point to the vertex, or directrix to vertex, you can always find that by using what's here, because they say the directrix is the line x equals negative p if h is 0, which it is. So compare that to x equals negative 8, you can see that p is 8. So that's what goes right here. Okay, this next problem is really tough because you got to take this conic section, you have to put it in standard form. So unfortunately we're going to have to complete the square. This is not going to be that easy, but we can do it. So basically we're going to move everything to the right because we have x squared. So we know we're dealing with a parabola in that situation. We actually know that when x is squared but y isn't, we're dealing with a parabola that opens up or down. So we are going to complete the square on this by moving these things over to the right. So this gives us negative 28y plus 227. All right, so we're going to add something to both sides to make this a perfect square trinomial, which in this case is b over 2. So it's negative 10 over 2, which is negative 5 squared. We always add b over 2 squared to both sides. Once a is 1. So this turns into x minus 5 squared. It's a perfect square trinomial. And then I have to add 25 to this side as well, which is 252. Okay, now I could solve for y, for example, and put it in vertex form, or I could keep it like this. But now we have it in standard form. If we compare once again to what we have here, we have this equation right here, x minus h squared equals. Now I'm going to try to simplify this so I can get it factored into like y plus or minus something right here. I can actually pull out a negative 28 from this, and it leaves me with y minus 9. So that's the same thing, just factor out a 28. Now I'll write that up above here. So this is y minus 9. And compare it to standard form, which would be 4p times y minus k. So k is 9, p is negative 7, and h is 5. So the vertex is at 5, 9, and p is negative 7. Okay, so for this one, obviously this is a parabola then. And then something's going to be hard to answer. So the first focus of the conic section, I mean, we could give the focus to this thing. We're looking at a parabola that's in this column, so we're talking about this information. The focus then is at h comma k plus p, which would be h is 5, so it's 5 comma k plus p would be 9 plus negative 7, which is 2. So that's technically our focus, 5, 2. For some reason it's not accepting some of these answers though. There's not a second focus, so I'll just leave that blank. The equation of the directrix is right here. It's y equals k minus p. So k is 9 and p is negative 7. So that would technically be k, or y equals 16. And then they want it to be equal to 0 though, so we'd have to subtract and make it y minus 16 equals 0 and enter it in that way right here. But for some reason none of this is working. I don't know. The axis of the conic section, I mean, the axis I'm not sure. I guess I'm not sure what they want for that, but it's a parabola that opens up or down. It goes through the point 5, 9, so it goes 1, 2, 3, 4, 5, up 9, and the focus is here, so it goes like this. So technically the axis would be like x equals 5, for example. But instead of entering x equals 5, we can subtract 5 and do x minus 5 equals 0. That seems to be the way they want us to enter it in. And then there's no asymptotes for this. It's a parabola, so I would leave these blank. That's the right answers as far as what they asked, but for some reason this isn't working, so we'll have to just throw this question off or something when I go to grade it. Okay, problem 5. We want to find the vertex, focus, directrix for the following functions. So we're going to use this table of information again. We have y squared here, so we're looking at a parabola that opens right or left here. So here's the equation in standard form. I'm going to write that right above here. We have y minus k squared equals 4p times x minus h. So you can compare and see that, okay, h is 3, k is 2, so my vertex is 3, 2. P is 4 because 16 has to match with 4p, so if we know that p is 4, we can use this for the focus, which is h plus p, so it'd be 3 plus 4, which is 7, and then comma k. which is 2. Then the directrix is line x equals h minus p. So that'd be 3 minus 4, which is negative 1. All right. Next one's a little tricky. I actually have to put this, I have to rearrange this somehow. So we can complete the square on the left side. We can make it y squared minus 6y. And then we're going to add b over 2 squared to both sides. So b is negative 6, divided by 2, and you get negative 3. So we're going to add negative 3 squared to both sides, which is really just 9. So we have 4x minus 3 squared is really minus 9, and we're going to add 9 from right here. So that turns into y minus 3 squared equals 4x. We simplify this, and if we look at this then, and compare it, we have y minus k squared equals 4p times x minus h. We can see that h is 0, and we can see that k is 3. So the vertex is at 0, 3. We can also see that p is 1. And if p is 1, we can use, we know we're in this column right here. To find focus then, we would do h plus p, so it'd be 0 plus 1, would be 1, comma k, which is 3. And the directrix is line x equals h minus p, so it'd be 0 minus 1, which is negative 1 again. All right, and obviously you're going to do pretty much the same thing for the last two. Make sure you got to complete the square on this one, for example, by adding b over 2 squared, which is 32 over 2, which is 16 squared to both sides, to make that perfect square trinomial. So you can get it in a format where you have like x minus something squared or y minus something squared, because that's the way that our formulas are. So we have to get them in these forms in order to be able to determine what h, k, and p are, to be able to find the information they're looking for.